So this is my second webinar under the umbrella of qcrete Readymix India Private Limited, and it is the fifth webinar of qcrete. I thank my friend and managing director of qcrete, Shelly Fernandez, for giving me this opportunity to talk to people all over the country. The subject which we are going to talk about is use of hydraulic concrete pumps. I'll give you a brief history before I start my lecture. 15 years prior to the construction of unit number 5 at Bombay, Tata Electric companies had constructed unit 4, a 150 megawatt power project at Bombay, using mainly labor for doing construction work. The management had faced serious problems for doing voluminous concrete works by way of labor shortage, strikes, and stoppage of construction work on several occasions. It so happened many a times senior management people like the project manager, the general managers, etc., had to carry concrete in the gamela and help the balance workers who are there in the field to complete the job. The thought of mechanization took place during these problems, and the management decided that in future, if there is any large project, we will do it in a mechanized manner. So these were the first steps to purchase the mechanized concrete equipment, which I will show you a little later. And I was one of the lucky engineers to be benefited by this new and state-of-the-art technology using computerized, mechanized, and remote control equipment. Later, as the Unit 5 was coming to a close, the management was recommended to procure a truck-mounted pump and placer boom. And in the next project, unit number 6, we were lucky to have this equipment along with the others which were procured in unit number 5. So the Tata Electric companies were the pioneers to start the use of hydraulic concrete pumps. But pumps alone cannot deliver quality concrete. We had to have the entire setup of equipment. Concrete using pumps is like fluid concrete from the tap. But there are many things which go into this concrete, and the Tata Electric company's engineers had to face a few teething problems, which I will be covering as we go along, as well as we had to see that the work also picks up a good speed, at the same time delivering quality in the concrete which was to be placed. So we got the first experience in India in 1979 when the first 500 thermal power plant of the Tata Electric companies, then called TEC, at Bombay commenced. Gammon India was assigned the contract to carry out the major civil works. The contractor manufactured, supplied, placed concrete using imported equipment from Germany, Switzerland, and UK, costing rupees 6 million, and the entire set was purchased by the Tata Electric companies, the clients of the project, which is quite unusual. People often depend on the contractors to bring their equipment, but here Tata Electric companies took a great initiative for which many engineers benefited, concrete benefited, and we had a very strong and good construction done because of this initiative. The following equipment was purchased: computerized batching mixing plant. Has the slide changed? Oh no. I know. Okay. Sorry. Computerized batching mixing plant of 60 cubic meters per hour capacity. I think it's taking a long time to see on. Can you see the slide? Shelley?
Yes,
okay.
sir.
Now it has come. I think it is a little slow today. So we purchased a 60 cubic meters per hour plant, which was completely computerized, but it can be run on a manual mode like a normal concrete, ordinary concrete, where the operator has to press one button at a time for each ingredient, release the button when the adequate quantity by weight has fallen into the batching pan. It can run on semi-automatic. One button is pressed and the concrete is produced by the computerized batching plant with the help of a data fed into it prior to starting the plant, and one at a time, 1 cubic meter will fall into the transit mixer below. It can work fully automatic. It had the provision to do concrete up to 6 cubic meters, because in those days some of the transit mixers had a capacity of 6 cubic meters, the ones which we had purchased from UK, and therefore at times it was run fully automatic. If small quantity smaller than 6 cubic meter was required, it will be run under semi-automatic mode. The concrete pumps of 60 cubic meter capacity per hour were purchased, and they work beautifully. And we all know that in the site conditions, they have to be rough and tough, and as well as deliver quality of concrete. We had gate valve operated trailer mounted pumps purchased, and they gave us a very good service. I used to call them princesses because they needed very good food, that is the concrete mix, and if the entire setup of pipeline etc. was done properly, they delivered the goods. But my guru, Mr. Remedios, said no, they are not like princess, they are like the rough and tough farm girls, and therefore I used to call them farm girls in our project. The transit mixers which we purchased from UK had single engine. One engine could run the truck as well as the mixer. And to deliver the power to the mixer came through a cardan shaft and a pump which was located, and we called this pump as the heart of the transit mixer. We were also fortunate to have remote control tower mounted placer boom which could also run on a rail track below, run parallel to the building, and the boom can stretch comfortably with a reach of 40 meters. Whenever we found that at a location where there were concentration of large volumes of concrete, this tower mounted placer boom was an asset. If one sees the brief history of the pumps, in the earlier days, pumps were used to do concreting in tunnels, but they were mechanical pumps, just like our water pump. And more or less you can see the early days pump looks as if it is like a graniting machine. However, our pumps are run by a hydraulic system, and the entire hydraulic system is controlling the working of the pump. We had purchased 550 HDP, very suitable size for India and capacity, which could pump even up to 100 meter vertical and 400 meter horizontal concrete delivery through the concrete pipes, which are made up of steel, of course. As development advanced, and in countries like China and Europe, higher structures were being constructed, more powerful, highly pressurized pumps were used. First in the Kinky Building Financial Project in China, which was supposed to be the 8th tallest building in the world. And later on, of course, the famous Burj Khalifa was also constructed using Putzmeiser's BSA 14,000 HPD super high pressure pump, and they broke the vertical record of 600 meters in one go. Now, pumping is the only way you can deliver concrete both horizontally and vertically in one go. So, in my opinion, it is the most convenient way to do construction. If you take a look at the working of the pump, the flat wall gate system, the mechanism which we had in the pumps which we imported from Germany, company called Schwing, they had gate valve system and it worked quite beautifully. And even if an oversized aggregate goes past the grill which is put on the pump hopper, it is sliced into two pieces by the gate valve. So the pump was very rugged, very good for rough and tough jobs. There was a water box which would clean the pistons with every stroke. And you can see that on the where I am putting the arrow, you can see that this is the gate valve. So it washes the piston so that nothing adheres to it during the operation. The inlet and outlet valve open alternately. As the inlet piston sucks the concrete, the other piston pushes the concrete outside. So this is how the concreting work was done. Besides flat valve systems, simultaneously or a little later, other systems were evolved, which I will show you. This is called a rock wall system, and it is called a Rock-Schieber wall system also in Germany. Rock-Schieber means a woman's skirt. So it is in the shape like a woman's skirt, going from the inlet piston to the outlet piston and conveying the concrete. You can see that sketch which is given on the side of the pump. Now these were supposed to be mechanically well balanced as compared to there were also simultaneously developments taking place all over the world. Now we started concreting using pumps in 1979. I had the opportunity to visit uh, some European countries like Switzerland and Germany, where these equipments were being made. And the swing people told me that the one the pumps which we have exported to India are the fourth generation. So already the fourth generation of hydraulic pumps had come in. Further development took place when the truck mounted placer boom and pumps were evolved. Now they wanted a more compact pump, so they had S-valve system and C-valve systems, which you see on the screen. And this came about when we imported Elba pump from Germany. The Elba pump had a boom placer of about 18-meter height or stretch, you can say, and a pump again of capacity about 60 cubic meters per hour. So on the screen you see the Elba pump being fed by the transit mixer, and it had a C-valve system which rocked inside from left to right, first sucks in the concrete and then pushes it out from the other piston by the other piston. A brief history of truck mounted pump and placer boom I am trying to give you is the pump mounted placer booms in the initial stages had all bends made up of flexible pipe like the one you see on the screen. Later on, there was a massive development of these pumps, and the flexible placer or bends, which were giving more frictional resistance, were reduced, and steel bends were used in the truck mounted placer boom. Some time back, the largest boom was 62.5 meters with 5 sections, and the boom was of a diameter of 125 millimeters pipeline. These booms were very large. The truck was very large on a 6-axle truck, and when they were traveling in Germany on their autobahns, which have no speed limits, they looked as if they were like huge dinosaurs on a racetrack and would be dangerous for smaller cars, and therefore they were banned and exported, one to Greece and one to Saudi Arabia, where there were lesser speed limits and safer for the other traffic. But very soon, of course, these pumps were truck mounted placer boom pumps were very costly. It was not owned by one RMC plant, etc. It was owned by a consortium of ready-mix concrete plants with several owners. So they used to do one place or the other, and it was shared, and the cost was shared by all the suppliers of ready-mix concrete. Then came a bigger invention, a 10 XL truck with a mammoth placer boom, and it could place concrete up to 70-meter stretch. So friends, inventions go on, progress takes place, challenges to engineers is supported by these equipment suppliers, where taller buildings are being built and faster work is required to be taken place. One very good innovation took place in the meantime. We used to always observe that when we do the concreting with a placer boom and change the position of the placer boom, some concrete would fall down either on the reinforcement or on the human beings below, and it was a bit of a nuisance. So the Germans developed a folding system on the truck mounted placer boom, which can be used even on a tower mounted placer boom, which squeezes the pipe, outlet pipe, when you are shifting the placer boom. Otherwise, the valve opens up and allows the concrete to flow when you are actually doing concrete work. This is the inside view of the then state-of-the-art batching mixing plant in 1970. And this was the first step in India to produce computerized concrete. And the people who benefited most were the operators of the batching plant. We had a big problem of training the operators, because once they get a bit trained, within a month or two, they get exported to Saudi Arabia or Dubai or various other more lucrative places. It was very difficult to retain these operators for a stretch more than 2 months. Now you can see the operator operating the table. Those days the tables were very big and so many buttons and all that were there. Now it has become easier, almost like a laptop or a desktop computer. The slot which you see, I am pointing the arrow there, is used to feed the card which has given the program of the mix you desire. So it was very instantaneous. If you want to transport some different mix, you put that card inside. Once you want to go back to your old mix, again you can put the card inside. The operator can see the weighment visually, as well as he can see how much of water is added and how the consistency of the mix looks like, etc. And one of the questions posed by me to the Germans when I visited Germany was, how do you know that the correct consistency of the mix is being put? And they gave me the same answer which many Indian mixer operators would use, is the eye judgment. So the eye judgment plays a very important part. Besides, the current consumed by the mixer is also a guide whether the current indicated on the device, on the computer, shows that it is within a particular limit, and therefore the slump should be okay. Later on, there was a big gap between 1979 and 1994. And in 1994, modern batching mixing plants were imported by few RMC producers, and which were of higher capacity, more compact, more comfortable to operate. And you can see a tabletop arrangement where the operator gets an alarm if there is any problem with the equipment and immediately that is attended to. These batching mixing plants had electromechanical weighing systems which were very accurate, totally unlike our weigh batching systems which we had in India, indigenously made, which used to go repeatedly out of order or we had to repeatedly calibrate them. These were very accurate, they were dust proof, and therefore they were very accurate, and therefore it gave much better quality. The admixture dispensing system, the batching plants or the RMC plants had, they could batch at the most 2 or 3 admixtures at a time if they wanted to. Generally, a single admixture was used during our days for dispensing, and the operator could look at the dispensing jar whether the correct volume is going in and what he had indicated in the mix on the card in the computer. Besides our batching plant, our batching plant had pan mixer, and you can see here the fins of the pans are so distributed at an angle, etc., and the arms are of different length. So within 30 seconds, 1 cubic meter of concrete is mixed. Within 36 seconds, 1 cubic meter of concrete is batched. So the total speed of the batching plant is 1 cubic meter per minute. This pan type mixtures were changed, and we now have mainly single and twin shaft mixers, which are, I am told, cost less maintenance costs are there as compared to the pan mixer. Now, there were arrangements that the blades could be changed both in pan mixer and single and twin shaft mixers, and which can be done very fast. So routine checking of the blades was necessary, but generally they gave a very adequate performance. There was also now electronic moisture measuring device, but many of the RMC people do not recommend that because they feel that the other whole system of eye judgment and measurement of slump are better indicators. However, I'm not sure whether they are trying out this automatic measuring system. Further development took place, and the pan mixer was fixed with an agitator. As the agitator revolved, it also spun and it gave good performance. This is another view. On the right hand side you see of the twin shaft transit mixer. Now, when there are very difficult mixes, like a mix with very stiff slump or low slump, then this pan mixer with agitator was being used. It has still not come into India. It is being used abroad. And not only stiff mixes are difficult, but also self-compacting concrete mix is difficult. Mixes using fine and ultra-fine material in high proportion are also difficult mixes. Mixing is difficult when you have large aggregate size. So all this was resolved and solved by the pan mixer with the agitator. Now just a few lines on materials. If you are using rounded shape aggregate, it is preferred. In India, generally we use crushed aggregate. Crushed aggregate has abrasive effect on the pipeline of the pump, on the hopper of the pump, on the transit mixers, the drum of the transit mixer, as compared to the rounded shape. Many engineers feel that gravel or the rounded shape aggregate should not be used because it is smooth on the surface and there will not be very good bonding between the mortar and the rounded aggregate as compared to the mortar and the crushed aggregate. But this is a wrong notion. We used to use mild steel bars which were still smoother than the rounded aggregate, but still the concrete had a good bond with it. And also the world record of use of rounded aggregate is up to 90 megapascal strength. Now in unit number 5, the contractor preferred to use the rounded aggregate which was lying waste in Mumbai and Kalyan, and those mountains of oversized aggregate was brought to the site, sieved, and with great insistence it was thoroughly washed before it was put into the batching plant bins, so that we get proper and good concrete. There is many things. If the rounded aggregate is used, there are problems like maybe silt coating on it which will not bond properly. The crushed aggregate is free. It is not having any, it is not dredged from the rivers or some other places like ponds, etc. And it is likely to have a very clean surface. So it is preferred. Nowadays, natural sand is banned in India, so we have crushed sand, which is a welcome thing, but crushed sand has a disadvantage. You have to have a proper mix and avoid the finer dust which enters into the mixer along with the crushed sand. So there are limits specified by the standards and one has to comply with it. As far as water is concerned, preferably use potable water, but ensure that if there is a well water or some other source of water, that water is chloride free. And also there is a limit for the pH value in the water. Cement, any cement can be used. OPC, PPC, slag cement. However, people prefer to use OPC along with fly ash and slag addition because it is economical, especially because the ready mix companies are running at a very narrow margin of profits. So they prefer ordinary Portland cement. If the concrete has a very high strength specified, then they prefer 53 grade. Otherwise, they prefer a 43 grade ordinary Portland cement. Cementitious materials like fly ash, slag, microsilica, ultrafine sand, ultrafine fly ash, ultrafine slag, all these are used in concreting, but they have to be used as per the standards which specify their various properties. If a non-standard or substandard material is used, then of course you will have problems of not getting the correct quality of concrete. Admixtures. These days admixtures are causing a little bit of problem, and it is observed that the concrete does not set for some days. I always compare admixture addition with that of alcohol. Alcohol has same effect on human being as admixture has on chemical. If you take excess alcohol, the human being also goes to sleep and does not wake up for a considerable amount of time. Same thing, the concrete goes to sleep for 6 to 7 days or more because the dosage is been in excess. So one has to be very careful, especially adding plasticizer after the transit mixer has left the batching plant is, in my opinion, dangerous and is causing this problem of excess dosage. Compatibility with cement and mineral admixture is very, very important as far as the plasticizer is concerned. So one has to work out good compatibility with cement and mineral admixture when they use chemical admixtures in their mix. And obviously chemical admixture being the smallest quantity has to be compatible with the cement or the mineral admixture which the owner of the plant proposes to use. Pump output will definitely depend on the workability, that is the slump and cohesiveness, the type of aggregate, the size and the shape, the length and diameter of the pipe, and the pump capacity or the line pressure. Now every pump has a capacity to put a certain line pressure. If that capacity is exceeded, then automatically the pump will get choked. I'm showing a few aggregates of different shapes. In European countries, still high strength concrete is being made by the gravel or the rounded shape aggregates. In India, crushed aggregates are preferred because very seldom you get rounded aggregates, except in the north you may try gravel, and if it is oversized it can be crushed. In Bombay Unit 5 also we have used gravel, and all the oversize was screened and kept separately, and later on it was crushed. So we got a semi-rounded, semi-crushed surface, and we had to make a mixed design estimating or guesstimating the rough type of surface as compared to the rounded surface which one used to get. A good pumpable mix looks like the one on the top. Obviously, it has a nice coating of the mortar around it, and also at the surface the mortar works as a lubricating agent. The badly pumpable concrete looks like this, where there is a lot of cluttering of the aggregates, and these days we are very used to the problem of the COVID. So you have to have a safe distance between the aggregate to have a good pumpable concrete and not the other way around. Precautions required for pumping concrete. Concrete must be of a consistent quality, and that is very difficult to get because many a times the materials which we put into the concrete are not of consistent quality. So again you have to go to the source and get consistent quality aggregates, consistent quality cement, water and other ingredients. Now when concrete is put in a pipeline under pressure, pressure from one side, the resistance comes from the roughness on the surface of the pipe, which is also supposed to be very smooth inside. But when concrete column gets squeezed, anything you squeeze, the juice comes out, and the juice of concrete comes out and acts like a frictional resistance or lubricant between the concrete column and the pipe surface. So when you design your mix for a pump concrete, you have to give more thought to the fines, ultra fine material and the fine material which you use. Sometimes fly ash is preferred because fly ash also has rounded particles and will give better lubrication. Slag is preferred because it also has the calcium oxide and you can use greater addition of slag as compared to fly ash. So it all depends on your mix, who is the operator and how we want to adjust the various constituents depending on the economy of the concrete. Now you can see here a pump which is a mix which is having high pressure. It is generally due to a lot of fines and fine material and low workability. A mix which tends to segregate is also unpumpable because under pressure the aggregate remain in the pipe while the motor coating them gets pumped out, and therefore you get a honeycomb like blockage. In the earlier instance, when the mix is stiff, the concrete looks intact, but it is too rigid to flow under the pressure which is recommended for the pump. Now, tips for tackling the unforeseen stoppages. Stoppages can be tolerated up to a certain duration depending on the mix consistency, ambient temperatures and concrete temperatures. Mix consistency, if the mix is fluid, self-compacting, then very good, or if it is having higher slump. Ambient temperatures are not within our control, therefore the mix designer should always keep a thought about the ambient temperature prevailing in the days when he is doing concrete. Concrete temperature will depend on many conditions. Concrete temperature will depend on the temperature of individual ingredients, as well as the type of cement being used, as well as the temperature of water which is being used and mixed. Because generally we store water on the site in black tanks which absorb heat. So the temperature of water is much higher than the ambient temperature, and also hot water will react with cement much faster, and once cement starts reacting fast, there are chances of stiffness coming into your mix, or the slump will drop and you will have problems of either choking or you have to put some ice in it or cold water in it to reduce the water temperature. Long stoppages can cause choke due to concrete stiffening inside the pipe. As a precaution, always maintain enough quantity of concrete in the pump hopper. Now, many of the pump operators are not trained to do this particular thing. They hurriedly empty the pump hopper. sometimes causing even an airlock, sometimes causing a problem of choking. The choking occurs because it is recommended that when there is a stoppage, every 5 to 10 minutes, one stroke of pump should be given to prevent a permanent choking in the pipeline. But if there is not enough concrete in the hopper, then this particular problem will be there, that the operator won't be able to give enough strokes till the reason for stoppage is rectified. And if it is a very long duration, then you are in trouble. Improvement of pumpability due to fine and ultra-fine material. Ultra-fine material forms a good lubricating layer in the internal surface and creates a very good lubricant to assist pumping. Reduce wear and tear of the pipeline, and chances of stiffening in the pipeline are also reduced. Now here you can see the hopper of the pump and the transit mixer feeding the concrete. Many a times, the best remedy is to have the hopper full till the bottom of this grill. Due to safety reasons, these grills are put. We used to observe in the initial stages that because of the mix getting slightly stiffer, it would not fall through the hopper, and there was a poking device used by the operator, you can see here, to let the mix flow below the grating. This was a tiring work for the pump operator, and therefore he used to resort to shortcuts of removing the grating. Once the grating is removed, there are chances that oversized aggregates, some material like a wooden piece or a cloth piece, may enter the pump and damage the valves. This grating is meant to arrest the oversized materials, and this grating is put for the safety of the pump operator, because if he accidentally puts his hand inside, there is a blade which is rotating inside to churn the mix so that its consistency is constant, workability remain good, and therefore what used to happen was, in spite of several requests to the pump operators, they would remove the grating, and hence we had to weld the grating to the pump and cut the weld whenever maintenance of the pump was required. Sometimes we have to make the donkeys work. Prevent mix segregation and chokes. The fine material gives a very cohesive mix, very good mix for pumpability. A brief history of transit mixers is necessary. Now, when the RMC concept came in, the mix needed to be transported. We could not transport the mix in a truck because there will be vibration, and when there is vibration or any jumps on the road, the mix will segregate. And then when you have to feed a truck carrying concrete mix into the pump, it is very difficult. So these transit mixers were developed early days, maybe somewhere around 1930. And now you can see the modern days mixers. This was the initial transit mixers developed in India, produced in India, somewhere in 1980. But it had twin engine, and those engines were very large on the chassis. They had a lot of weight to carry in addition to concrete, and therefore the capacity of these transit mixers in generally in 3XL trucks which had come from UK, we could carry 6 cubic meters, while here only 4 cubic meters can be carried on this chassis. Now, twin engine transit mixers have an advantage naturally, because if one machine can go wrong, it can be coupled by putting the transit mixer next to that and operated, and you can unload the mixer conveniently, and or if it has to be repaired, it can be taken back to the plant where the transit mixer machine is repaired. Well, if the engine of the truck fails, then there are simple remedies. You just tow the truck with another truck or a tractor or a towing machine, which would take the entire transit mixer to the plant. There is a very significant development taking place in transit mixers also. The transit mixers have become larger. 12 cubic meter transit mixer you can see here, but even bigger ones have come into being because of the demand of larger volumes of concrete. Now you can see the record of concrete placing has improved greatly. 230 cubic meters were placed in 6 hours. Later on improved to 1,578 cubic meters placed in just 9.5 hours. And then 16,000 cubic meters placed almost in 23 hours or 1 day. Just to show you the advances made in the transit mixers, you can see the photograph. Huge transit mixers on trailers of much higher capacity. I would not be sure how much, but it would go up to even 30 cubic meters. One of the records of large concrete pumps, concrete quantity done in 58 hours using 258 transit mixers at the rate of 1,034 cubic meter per hour. This record was achieved by the second financial center in Shanghai, which is, I think, which is about 4th or 5th tallest building in the world today. A little bit of mechanism we should know. It's like a screw conveyor. The screw is mounted in the inside of the drum of the transit mixer. When it rotates in clockwise direction, it agitates the mix. In the anti-clockwise direction, it unloads the mix. But this mixing is very inefficient as compared to the batching plant mixing. And we say that, okay, the mixing is not enough, only agitation can be done so that the mix consistency and workability do not fall down to a great extent. Very simple to operate. It operates on 3 lever system at the rear. Sometimes the operating systems are in the driver's cabin only, so that the driver can operate sitting inside and you don't need an additional person to operate these levers. The first lever is for adding water if you need excess water which is stored in the drum. The second lever is to increase the number of revolutions per minute of the transit mixer, should in case when the transit mixer arrives at site, they speed up the revolutions so that the mix gets properly mixed. And in case the engine is not able to take the load, then to raise the engine power, a third lever is kept. The sound which the engine makes, the truck engine, that is to raise the engine, and we often face it during the signal on the road. When it changed from yellow to green, the trucks are all ready to move and they raise their engine and move, trying to overtake the other trucks or the vehicles on the road. Some of the specifications in the world, the standards ban carrying water in transit mixer drums. In India, it is still allowed, and I think because of the hot weather, they may need little excess water to be put in the transit mixer. But then at the batching plant, they should put less water, otherwise the water to cement ratio will change and you will not get the desired durability. Even at times, admixtures are added along the journey, which I have already said that they can create problem of the concrete not setting, and this could be serious implications. The RMC operators may not get paid for it, and even if they get paid for it, they will have tension moments for the next 7 days. A twin fin transit mixer have been developed. In many European countries it is used. It is an excellent substitute when you use only batching plants without any mixers. This mixer can agitate and mix the concrete as efficiently as the batching plant pan mixer or shaft mixer. Another thing was, if the mixer is traveling in a shorter distance, not many kilometers away to the site, then this mixing is enough, because by the time within say half an hour or 10-15 minutes, as the transit mixer reaches the site, the mix is ready to be pumped. Now this is an excellent view of our Unit 5 turbo generator, which is ready for concept concreting.
Hello. Okay. Now okay. You can continue.
Okay. So this is an excellent view. You can see the tower-mounted placer boom pumping concrete. The truck mixer, one pump is here and the other pump is here. Two pipes are there connected to the tower-mounted. This was one of them is a standby pump. Only one is working at the moment, because we could easily get comfortably get about 40 cubic meters per hour, which was required for placing the TG deck. One thing important is you must always cross check the bar pressure and the pressure due to various types of arrangements you have done on the pipeline. How much is the vertical pipe, how much is the horizontal pipe. So for every 20-meter horizontal pipe, 1 bar pressure will come, and for every 4-meter vertical pipe, 1 bar pressure will come. The startup pressure will be 20 bars. Each bend will have a different pressure. Pipe coupling will have different. End hose will have a different pressure because it's a flexible hose, higher pressure. The most important precaution one has to take is total these pressures and keep a safety valve operation at 90% of the set pressure. The hydraulic systems all depend on the pressure. If your pressure exceeds the safe pressure, there are likelihood of the small pipes conveying the hydraulic oil to the different parts of the equipment may fail. And as a result, there will be a serious maintenance involved and stoppage of work. Even our compression testing machine, which is also run on the same principle of hydraulic pressure, also has to be set at 90% of the safe pressure, so that no unforeseen stoppages or bursting requiring the replacement of the pipes take place. So always keep a 10% allowance on your bar pressures. Conversion can also be done when you are estimating what should be the pipe length and working out the workability as well as other parameters. The vertical rise for every horizontal, it will be 2 to 3 meters for every vertical 1 meter rise. That means if you are pumping concrete horizontally, you can do it much better, but if you are going vertically, you need to calculate it to double or 3 times the pressure. 90-degree bend will obviously take more length conversion. 45-degree will be 2, 30 will be 1, rubber hose could be 2 meters. And depending on the total number of bends, the total horizontal and vertical length of the pipe, you calculate the total length of the pipe. On the screen you see, this is a photograph I have taken from a magazine. There are the bridge piers being cast in USA. But one lesson which I want to convey to you is that the pump should be approachable from both the sides. Many a times we plan our pump placement in such a way that only from one side the transit mixers can come and feed the concrete. Should in case that one approach gets blocked or waterlogged and you have a problem, then your entire pump operation will get disturbed. So the pump should be positioned in such a way from both the sides the transit mixer are able to feed the pump. What should be the thickness of the pipe? It is recommended that for tough pumping jobs, very high-rise buildings, vertical pipe should be at least 7 millimeters thick. For larger lifts, medium workability concrete, 75 to 25 plus or minus 5 meters. And for horizontal distance, 4 meters. Now generally what the clever operator will do is, when the pipes get worn out, he uses them for horizontal short distance or maybe sometimes for large lifts, but with good workability, he can replace them. But for high rise and tough jobs, 7 millimeters is required. This is a pump concrete performance estimator. The first quadrant which you see here is the length of the pipe, sorry, the line size, the diameter of the pipe, because line size also controls various other parameters. And suppose you are fixing your pumping rate, say you want to pump at 25 cubic meters per hour and you have a 5-inch pipe, Generally 5-inch pipes are used in India, but some of times the truck mounted the truck mounted pump and placer boom has smaller diameter pipes. Like for example, our Elba had 100 mm pipe diameter, but the swing pumps had 125. So we take suppose 125 and then go down to the pumping distance, which is the horizontal distance converted, all the verticals, bends, etc. converted to horizontal distance. And we assume that it is say 400 meters. Then what is the slump which you are using? Say we are using 80 millimeter slump. And then we go to the line pressure, which is coming to about 36.4. And therefore, our 40 cubic meter per hour pump should be having adequate line pressure and can be used. And we can get, not 40 line pressure pump can be used, and we will get about 25 cubic meters of pump. We have to lubricate the pipeline and the pump hopper, and we also call it, in the other words, is buttering the pipeline and the pump. So maska you have to lagao to make sure that the pipe functions well and the pump functions well. Generally 50 kg of cement with 25 kg of sand are mixed in thick consistency. It should not be cement water, it should be cement mortar, and should have a reasonable thick consistency per 20 meter pipe length. Now this is very, very important. Many a times people are using cement water. That is not the correct thing, because you need fine materials also along with it, like sand or maybe fly ash or slag or whatever you want to put. And these days ready mix buttering mortar is also available, but this is a most economical and more reliable solution than buttering mortar. Now with a series of slides, I can show you how good quality concrete can go bad due to bad placing. Concrete must be placed avoiding segregation due to obstruction of formwork, reinforcement steel and inserts. All the hose pipe operators and the supervisors and the pump operators should be aware of the same. Now what happens is, if the hose pipe is not properly placed, it will hit, the concrete will hit the bars, and you can see mortar sticks to the bars. And what falls below are the stones, and those will cause segregation, caused by segregation, and will result in huge porosity and loss of durability to the concrete. I will later on show you how to do the correct thing, but let us show some more nonsense going on. You go with a camera to photograph concreting going on, and the attention of the worker is on the camera, not on the pipeline. He is dropping the concrete and again disintegrating or segregating it at the lower end. Sometimes the supervisor does not know what he is doing. He is pulling the hose pipe across a pedestal reinforcement, so he is segregating the concrete much more than what the worker would have done when he is dropping the concrete from the top. Realizing that he has been photographed by the quality control engineer, he quickly summons a mason whom I call the ward boy of the concrete operations, to clear all the mess he has done. Whenever you are doing pump concrete, it's a huge quantity coming out, almost like an elephant suffering from diarrhea. One ward boy cannot clear all that shit. At the end of the day, when the concreting stops and it is time to remove the formwork, you get surprises like this. Huge voids, not like, I mean, these are not the father of the nation. He could not have gone inside and put his footmarks on it. But these are almost resembling rat holes. Of course, some honeycombs are also there. And this concrete would be very weak because of the voids. So loss of strength, and also due to porosity, loss of durability. How to do your concrete correctly in deep foundations? There should be adequate spacing between the reinforcement steel and the pipe sleeves which you place. The internal diameter of the pipe sleeve should be about an inch larger than the hose pipe of the placer boom. Then it can safely go inside. At the ends where there is a cover to be maintained, if it is a 60 mm cover, proper 60 mm bars should be put, and the spacing between the reinforcement steel should be more than 60 mm, almost a little more, so that the needle vibrator, which is of 60 mm diameter, can comfortably go inside. If this does not clear the density of the reinforcement, you are allowed to bunch the bars. Preferably avoid any horizontal laps at one place. You can stagger the laps. Alternative is also to use bigger diameter bars instead of many smaller bars. So this will permit you to reduce the segregation and have more comfortable way of concreting. Here you can see the placing boom hose goes right inside that pipe sleeve, goes right up to the top of the bottom reinforcement. There were 3-4 layers of reinforcement within this 6 meter depth foundation, 3 meter depth, sorry, 3.5 meter depth. Here it is 3.5 meter, here it is 3 meter. So if you can avoid segregation, you can see not a speck of mortar on the bars or any obstruction. The concrete has gone in the foundation properly and compacted properly. So this was a correction which we made and implemented. In Unit 5, we were not that successful. A lot of expenses had to be done by way of repairs. And in Unit 6, we did a good job from the previous experience. We covered up all the defects, likelihoods of defects, etc. Trained the operators properly, planned the reinforcement much before it was placed on the site, and therefore our efforts were rewarded. With good quality concrete, we got also good quality finish. Coal joints often come, and the problem in Unit 4 was whenever we did large pours and the workers struck and requested the management for higher wages, and otherwise they would abandon the work. So there was always a threat of coal joint taking place. Coal joint, especially in foundations, is dangerous because it can be a source of leakage and later on cause corrosion to the bars which are put in the foundation. In the superstructure also, it can cause a problem of durability. However, in reinforced concrete structures, there is no danger of a coal joint causing a collapse of a structure because the bars can take enough shear and protect the structure from actually collapsing. But coal joints, as far as possible, should be avoided. Some places you can't avoid because whenever you are building concrete in stages, you have coal joints at every stage. The concept of avoiding the coal joint is in one single pour is that the lower layer of the concrete which you have put earlier should also have not set. At the most, you can tolerate a little bit of initial set. When the subsequent layer is put, the needle vibrator should go through the top layer into the lower layer and stitch the two layers together, just like two cloths being stitched by a needle. So here the bonding will be much better when you place the concrete from the top and the vibration goes right through the bottom layer or right up to the bottom layer through the top layer. Many a times there are deep concretes where you need proper set of eyes to see whether the concrete is traveling below the bottom reinforcement. So many a times you have to send the worker within the cage, but make sure that the worker is out of the cage when the concrete is finally at a higher elevation. Otherwise we'll get many princesses getting and princes getting buried in the concrete. Big columns were a challenge to put. We did 14-meter columns in unit number 6 in one pour because the specification of the turbo generator stated that the TG deck should not have a joint. The columns of the TG deck, there were about 16 numbers, should not have a joint. These columns were almost 2 meter by 2 meter, very densely reinforced. This is the reinforcement not yet completed, it is still going on. Here it is still less. So one had to use the placer boom which goes right down to the bottom and then retrieved gradually as the concrete quantity went on piling up in the column. This prevented segregation. This also prevented repeated use of formwork, etc. The vibration was done through windows which were put at predetermined locations, and therefore we got a very good finish, and we could do 14-meter column densely reinforced with proper arrangements. Walking uphill is difficult, but pumping downhill is problematic. Now, pumping downhill, we tried in one of our hydro stations where the anchor blocks had to be concreted and they were massive anchor blocks. So we positioned the pump on the upstream at a higher elevation, thinking that with the gravity the pump will pump better. But no, sir. The problem happens is many a times the concrete just slides down and creates air pockets, and many a times you see even in water lines we get airlocks. So we started getting airlocks, and the concrete pump would not pump. Ultimately, we decided that we will pump from the downstream and upwards into the anchor blocks. And that worked beautifully because our pumps were quite powerful and we could get the mix go very easily. Now what happens is when you are doing downstream pumping, I mean slope, down the slope, and you are putting the initial mortar for buttering the pipeline, the buttering only takes place in the bottom half. So the problem is the top half of the pipe does not get buttered, and that eats away the mortar of the subsequent concrete and chokes the pump. So if you are having a problem of a sudden drop in the pipeline when you are doing concreting of a raft, when there is a drop taking place of about 2 or 3 or 4 meters, it is better to use a stiff ball. Stiff sponge balls are available by the pipeline suppliers. You put it inside, or by the pump suppliers, you put it inside and then subsequently put the mortar which is used for buttering the pipeline. Now what happens is the stiff ball will block the mortar, and when the pump exceeds pressure, it goes down slowly down the pipeline and comes out at the open end, and the pipeline is buttered completely on full surface, top and bottom. If it is not done, I have seen chokes taking place in Mumbai when they were doing one of the rafts and they were not using a ball. I had to tell them to buy a ball and bring it and use a stiffer ball. There are softer sponge balls also available, but here you need a stiffer ball at the front and maybe a softer ball at the rear. So this is how generally this problem is avoided. In general, if the pipeline is inclined downwards or vertically downwards, of course, as I have said, it is essential to put a sponge ball before putting the grout or the buttering mix. Pipeline should be slightly given a slope upwards towards the pump in normal circumstances, so that the lubricating mix butters the entire surface in the pipeline. Another precaution is the clamps and the joints should be properly sealed, as under pressure they will start leaking and the water or the finer material may seep out of the pipeline. Don't use unusually long rubber hoses like one being used here. There might be kinks inside. As a result, they could have a choke. So it is very important that long end hoses and hose with large diameters are not suitable for concrete distribution. This is a very interesting slide. Now we faced once a stoppage in unit number 6, and I was in the office and my assistant rang me up and the site engineer rang me up saying that the pump is not pumping. I said, what happened to the pump? Mix is good and we are pumping only up to 60 meters elevation. We have done 75, 80 meters elevation also with the same mix. What should go wrong? Is the patching done properly? Then suddenly it struck me, I asked the site engineer, what is the distance of the pump from the vertical bed? And he says it is almost flush to the structure. I said, then you have done a mistake. You put it away from the structure, at least 10 to 15 times the height of the pipe. Then he said, sir, then the pipeline length will increase and all the more difficulty the pump will have to pump the concrete. I said, no, you try it out. So with great reluctance, the site engineer and my engineer agreed to put the part the way I directed them. I told them the reason was that now you have a counterbalance of the entire load which is on the vertical side. There are on battery down trees. So when they pumped the concrete vertically, they were successful because there was a balance being maintained because of the horizontal line of 10 to 15%. This is a must. Don't worry about the length of the pipe slightly increasing, and that also horizontal line. Here what happens, that with every stroke, because of the hydraulic pressure on the top,
Hello. Huh?
yeah, this is charge. So what happens was that the vertical pipe, which is full of concrete, creates a pressure and the concrete slides down back into the hopper, and as a result you get a feeling that concrete is not pumping because there is absolutely no control on that. Unless you have a hydraulic valve at the end, it's a different story. That will prevent the sliding of the concrete back. But this is a very simple way you can avoid the pump getting unworkable, you can say. It's not choked, it is working, but it is unworkable to not allowing the pump to this thing. In case of very big heights, you can see here there are a hydraulic valve connection which is also controlled by the operator. Once he pumps, he again stops, pumps again, he stops the valve, etc., so that the sliding effect does not take place. But for a small height, it can be easily avoided the way I have recommended. Reason for blockages while pumping. There could be many reasons. The stoppage of concrete supply for a long time and the concrete has become stiff. As soon as you have this problem, please empty the entire pipeline and clean the pipeline, otherwise that pipeline will not be usable for the next pour. Defective concrete mixes. Each and every engineer at the plant and on the site should know how to design a mix and how to rectify a mix when the concrete work is in progress in case necessary. For that, of course, a training session is necessary and on the mix design and also on the concept of concrete pumping. Failure of the pump. Very rarely the pump actually fails. The mechanical failure does not occur. It may be sometimes that because of the excessive pressure, the hydraulic component of the pump may have failed. So therefore, you have to have only 90% of the pressure which the pump can increase, and that is adjusted by the safety valve in the pump. That must be done. Inadequate mixing of the concrete materials. Yes, sometimes the operator, instead of waiting for 1 minute, is in a hurry. He unloads the concrete earlier, and if the concrete transit mixers are not good enough to agitate the mix and the distance is short, this problem can occur. Defective pipelines with not properly seals available and leaking, or not enough clamps properly operating, then you have a little problem. Now, one thing is there, whenever you are working in the field and concrete is being pumped, you must not only keep your eyes open but also your ears open. Because just like a car indicating to the driver that there is some defect, and the driver says that something is wrong with the car, let me open the bonnet and correct it before the car stops completely. A pump also indicates defect in mixing or pumping or on high pressures. When the mix is slightly stiffer than what pump can digest, it makes this type of a sound, which I will do it or mimic it.
Yeah, yeah, got it.
Okay, okay. Now, when the mix is flowing smoothly, you will not get that tearing sound. It will be a very smooth sound and flow. So you can relax if the sound of that high pressure comes, immediately attend to the mix, immediately attend to the temperature, what is happening, because sometimes the temperature, ambient temperature can rise up very considerably. I remember in one of the concrete pours, we had planned for a 35 centigrade mix, taking actual samples and all that. But on that day of concreting, the temperature rose to 40, 42 degrees centigrade. And it immediately indicated that we have to increase our workability after properly controlling the water cement ratio, etc., and put a right admixture which will also retard the setting time, because setting time of the concrete suddenly dropped from 2 hours to 15 minutes. So sometimes 1 degree rise can play havoc in your pumping operation if you are not careful. You can see here stiff mix, the entire concrete comes out and falls like a lump of shit outside the pipe, and then after some time the pipe will get choked. So this is because the mix inside is dry, the outside, this thing, it has formed a plug-like concrete in the concrete, and therefore there will be a problem. This slide I had put during the workshops which we were taking for the engineers in Ambuja Cement, because we repeatedly got questions on hot weather concreting. And why does concrete slump reduce? A simple common sense question. So we investigated in all the causes. The first is, if the aggregate is porous and dry, generally people don't wet the aggregate before putting it into the mixer, batching plant or mixer. It is very important, let the aggregate absorb water so that it is surface dry at the most, or maybe having some water on its surface which you can correct as a moisture. So another good work it does is, we have learned in our physics class in schools that evaporation causes cooling. So if the aggregate is hot, taking the black color of the aggregate in a hot sun, it will also get cooled down. And that will be good for our cement hydration and good for our slump loss. The next is evaporational losses. The temperature of the ingredients will be sometimes so high, including that of water, that water evaporates before you have time to correct it. So as a result, the mix will become stiffer. The ambient temperature is not in our control, but temperature of the ingredients can be controlled by putting either colder water or ice flakes, etc. or covering the various equipments so that direct evaporational loss doesn't take place. The next important thing is cement hydration. Now cement starts hydrating moment it gets in touch with the water. Cement, if it has a higher C3A content, chemically will harden faster. If it is a finer cement, it will harden or consume the water faster and lose workability. If the temperature of the other ingredients is high, cement will hydrate faster. If the ambient temperature is high and very high so that the pipes also get heated up, along the pumping also, the concrete inside will harden faster. So what you do is cover your pipe with a Hessian cloth and sprinkle water continuously so that water will evaporate from the Hessian and cool the pipeline, and in turn the concrete inside gets protected. If it is traveling in a transit mixer, you can see the type of transit mixers they use in the Middle East in a desert, hot, dry climate, is to have a canopy with a small gap between the drum and the canopy so that when the transit mixer is moving, the air circulates and provides insulation. Even the tank, which is used for extra water, is also protected. If you can see here with a circular covering. So these are the important things one has to take care in hot weather concreting. Now we come to almost the end of the lecture. The last operation, just like in concrete, the last operation is curing, and it's very important that people forget to do it. But concrete to some extent will tolerate it. Your cleaning of the concrete pipeline, you can never forget to do it because next day you won't be able to pump the concrete. So one has to clean the pipeline thoroughly. The first operation is, if you are using a placer boom, make it fully vertical so that all the extra concrete slides down and is collected at the bottom. You can see here. Sometimes almost a cubic meter of concrete comes down like this. This was one question put to me to be asked to the Swiss people: what do you do with this extra waste concrete? So naturally in Switzerland they gave me a very simple reply: throw it away. In India, the contractor would not agree. No, I am losing 1 cubic meter even if I do 6 cubic meter worth of a column. So then we suggested, don't do 1 column, do 20 columns at a time. So he had to bring in more formwork. Again a question came, but I will be spending so much on the formwork because I will have so many. They said, but you have to do hundreds of columns on a project. Why are you cruising for 5 or 6 or 7 more columns? Formwork. Ultimately, he had to do that, and also suggested that, well, we will allow you to use this excess concrete which comes out to cast the speed breakers or the curbs on the road, and we'll pay you for it. So he was slightly happy, but then never bothered. He had always 1 cubic meter thrown out instead of making the curbs. But there are solutions. You can work economically also. Just you have to use your common sense. The cleaning out operation then continues after you have removed the concrete by vertically positioning the placer boom. Then you put a paper plug and a pipe. The plug, the ball, behind the ball, you push compress air. Whatever. The concrete plug is pushed by compressed air till the end. There is a basket safety. Sometimes what happens, ingredients like aggregate, etc., they just shoot out of the pipe and may hurt some people. So we have one paper plug, we have a catch basket, then we have a sponge, and then the compressors. So nobody gets hurt. After that, you do the line washing with water. So there is a column of water connected between the first ball and the second ball, and then the entire line is clean. The entire line gets completely clean. Mind you, if you don't do this extensive operation, which is not very difficult, you can really land up with chokes and problems the next day when you do your concreting. So with this, I am ending my lecture. I once again thank Shelly Fernandez and his team, which includes Ashwarya. And what is the name of the other person at Bangalore? Hello.
Yeah, Kaushika.
Kaushika, sorry. All these 3-member team, one working from Cochin, 2 working from Bangalore, and I am working from Mumbai. Thanks. I also thank my wife for her good guidance. Not that I am a handpack husband. And participants for your presence and good wishes. See you again in the next webinar, which we'll be conducting shortly. Shelly will announce the dates, and that webinar will be on an interesting subject of basics of concrete cracking. The engineer should know why the concrete cracks. There will be no solutions. You can do preventive measures, and why the concrete cracks is important. Because many a times people diagnose wrong cracking, and therefore they go in for wrong solutions. Thank you very much.
Good
Now,
afternoon.
you can play the song. Kaushika can play that song.
Yes, sir.
Yeah.
We are trying it for the first time on a webinar. A film song will be played. जिंदगी का सफर है ये कैसा सफर कोई समझा नहीं कोई जाना नहीं. And one, हाँ जी, you can start. The sound is not coming okay. What happened? Kaushika? Net challenge. Kaushika? What happened? Song is over?
Hello.
Yes. We are not getting the sound.
Hello.
Yes. Kaushika, I can hear your hello,
Yeah.
but I can't hear the song.
Yeah. Thanks to all the participants for participating in this webinar. One of the, I can say, one of the Pitamaha of concrete by Mr. Dordi sir. It was an interesting session, and I thank all the participants. Spread awareness on concrete, and we are continuously on the job of sharing knowledge through webinar series. We hope you enjoyed this webinar, and you can ask the questions to Shelly at qcretewebinar.com. Also, you can visit our website www.qcretewebinar.com. Dr. Q for asking any questions. We'll try to answer you. Thanks once again for all the participants, and thanks to our management for continuously doing these kind of webinars for spreading awareness on concrete and related technologies. Thanks once again to Dordi sir. Thanks a lot, sir.
Oh, it's okay.